Moinsen, this is Sebastian and welcome to the Q&A video about the GB Interceptor. If you've seen my previous Q&A video about the Wi-Fi cartridge, you will notice a few differences. First of all, this greeting. The last time you also saw me through a Game Boy, but then I used a real camera, streamed it via Wi-Fi through the Wi-Fi cartridge onto the Game Boy and filmed that with another camera. This time I used a Game Boy camera and the Game Boy Color with the Interceptor in between to record the video. And of course, I'm not doing the entire video this way, but instead, let's switch over to the real camera and put this little contraption away. Another difference that you will notice is that this here is not a live session. The other live session went, I think, 4 hours or something like that. And I asked you guys what you would prefer. And most of you said you prefer an edited version. So instead, you get a shorter edited video. This is not scripted in the sense that I'm reading off a script like I do most of my videos. But instead, I use a moment to think about the question and then I edit it down so we get a more compact video in total. I will categorize all the questions into 3 sections. So the first one will be about usage and capabilities of the GB Interceptor. The next one I would call meta, because that's about me and how I created the project, how long it took me, stuff like that. And finally, there will be the questions that require in-depth technical discussions. I will place them to the end so that those who cannot follow the complicated stuff are not put off by them. And of course, all questions will have chapter marks, so feel free to jump to any questions that you're interested in. Okay, let's start with the first question. What's the percentage of games you think do not work with this approach? Well, I think I can give a quite precise answer about this because in the wiki of the GitHub pages of the Interceptor, I now have a very long list of games that work and don't work. Let me show this one. So when you look on GitHub and go to wiki, there's this list of compatible games. And if we look at that, then yeah, you will see a green check mark for the games that work fine. Sometimes there's a little warning, but if it's only the warning, then there's a little detail that might look a little bit glitchy, but nothing that really puts you off. And often you have to look into details there. And the red crosses are the ones that really have a problem. Either the graphics are so messed up that you don't want to show it this way, or they crash, or maybe something more complicated is going on. Let's not have a look at the special cartridges, because I have to admit, I have no idea what the Blaze Exploder even is. It just got reported that it doesn't work. I had no chance to look into it. I don't know it. I think we're mostly interested in games. And this list is really long because of the help from these 3 nice people from Twitter and GitHub. Who did a lot of testing. But this still means testing is not necessarily that they really played through the entire game, because I'm sure they also have a life, yeah, if we look at this list. But I think it depends on which type of game. They usually tested it on different devices, so classical Game Boy Color, Pocket, a Game Boy Pocket. And usually for several minutes, maybe even 30 minutes in some cases. And if you look at this list, you see a whole long list of green check marks. You can actually easily count them if we look at the source code for this. So let's see how many crosses we've got. So that's 5 crosses minus the one for the special cartridges minus the one of the list of symbol explanations. Yeah, so we've got 3 crashing games. Okay, and if we look at how many are working fine, so let's count this one. We've got 186 minus the explanation minus these 5 entries, so 180. So I can give you an exact percentage of at least the games that were tested. So it's 3 by 180. So it's 1.67% of the games do not work. This, of course, may be a little bit misleading. First of all, this is the list of games that have been tested and where problems have been reported to me. So these are the games where I looked into fix. And the red crosses are actually the 3 games that I found so far where I think there is no good way to fix them. Where there really is a problem, which I do not see a way to fix them. I will not entirely exclude that there might be a solution, but these are really problematic. For the other ones, these are the ones that are, of course, fixed, and some of them include game-specific fixes. So if I have to guess, or maybe a good estimate is the ones that require version 1.1.0, because that's the one where I introduced game-specific fixes. I also fixed other stuff in there, and some games may work because of the other stuff, but many of those got game-specific fixes, and so 19 of those, so about 10% of them required specific fixes. This means that if you play any game that's not on this list, there is, I would say, about a 10% chance, feels about right, that it will not work because it requires a specific fix, and 90% of the games should work. And then, of course, maybe there are a few more of those games that cannot be fixed. Okay? So just to give you an estimate. Also, one warning, this is probably also an optimistic estimate, because as I said at the beginning, those games were not tested entirely until the end screen. So maybe there are a few candidates in there that still have a problem in a very specific situation, like a specific boss fight or something like that. I don't think that it's too common, because I mostly fix most problems, and most games do not change the way that their game engine works or the way things are rendered. But still, this stuff could happen. And yeah, if you encounter a problem, maybe a game that I didn't check and that needs a fix, or maybe later on in the game, please report it on GitHub so I can fix it, and we can really bring this list down to the very few edge cases that are really problematic. Okay, on to the next question. Does it capture color from GBC games? Yeah, that's something which I explain or mention in several places, but I think it's very important to emphasize this, because I've seen many people being surprised about this. The answer is no. It does not even support Game Boy Color games. So the problem is that Game Boy Color games they do not have to, but they can run in a double speed mode, which means that the CPU clock doubles, and the RP2040, so the microprocessor I'm using in the Interceptor, already struggles to keep up as it is. Actually, I even have to overclock it to keep up with the normal Game Boys. Maybe there's a way to optimize this, but at the moment I do not see it, and therefore I do not support Game Boy Color games at all. Also, because the entire rendering process, so the frame buffers, are set up to be grayscale only, and I might also have a little bit of a problem of RAM, although I'm quite sure that could be optimized. If it had to render color, I think we could make it work, but the problem is keeping up with the Game Boy itself. So this means that if you're playing a classical game on the Game Boy Color, that works fine, but you're not seeing the colors that the Game Boy Color adds, because that is actually done later. If you're running a Game Boy Color game on a Game Boy Color, it will not work. The Interceptor will simply crash or show strange stuff. If it goes into double speed mode, it will crash. If it does not do that, but then you will not see a proper image. And of course, there are also those games that support both. And these are the ones in this list that have the little rainbow next to the check mark. These are the cases where the game will work in a classical Game Boy, so a DMG or a Game Boy Pocket, but they will not work when you run them on a Game Boy Color or a Game Boy Advance, which pretty much has a Game Boy Color hardware in there for compatibility with the old games. Because if you run them in the old Game Boy, they will run like a classical game. If you run them in a Game Boy Color, they will run in color mode, and that's not supported. Next question. Can you use the GB Interceptor, Game Genie, and cartridge all at the same time? Well, I went to eBay, and behold, we can try this. Okay, so for this recipe, we need a Game Boy, a game, an Interceptor, and a Game Genie. The one important thing that you need to understand is that the Interceptor does not go between the Game Genie and the game, because if it did that, then we would only see, or the Interceptor would only see what the Game Genie receives from the game, game, but not what the Game Boy sees from the Game Genie. Okay, so it has to go the other way around. So what we need to build is the game goes into the Game Genie. So actually they go in this way. Then the Game Genie goes into the Interceptor. Let's see which way around. It's quite a puzzle here. I think like this. And then the entire contraption goes into the Game Boy. Yeah, and as you can see, this is mechanically a little bit challenging. So yeah, I do not dare to hold it at an angle. I can hold it upright and balance it on top of the Game Boy. That's fine. I can lay it down,
but there's no way I'm holding it at an angle that would work with the laptop display. So let me improvise some kind of ramp here. Let's try using this. Oh yeah, I think that works. Okay, yeah, that's quite a ridiculous contraption. Let me connect the laptop. I'm running out of hands here. Yeah, I think at this angle it should work nicely, especially because it's right in front of the light, which is why this part is now quite overexposed. But yeah, I think we can get the idea. Okay, and here we already see the interface from the not from the Interceptor, from the Game Genie. And I've looked up a code for Varioland, so it's and that should give us 99 lives from the start. Okay, let's try it. So never be surprised by this little short error message when you use something like the Game Genie or something, for example, an EverDrive. That's simply the Interceptor shortly losing the actual game because the Game Genie resets at this moment, just like the EverDrive usually does when you start a game. That's totally fine. It just comes back when the Game Boy starts over again. And for this test, let's just quickly delete the save game. I think there's no save game in there, but I use this for testing quite a lot, so let's be sure so that we really see that there are 99 lives when we start. And here we enter the game, and ta-da! It's 99 lives. Okay, so yeah. The result is the Game Genie works with the Interceptor, but yeah, you probably don't want to play like this. I mean, if you really want to do that. So let's turn this off so I can handle the thing again. One thing you could do is use the breakout board of the Interceptor. So if you use an Interceptor like this, where you, instead of soldering the cartridge header to the front, instead solder a pin header to the other side, then you can use a ribbon cable like this. And I mean, this ribbon cable is way too short for this still, but what you could do is you can connect the Game Genie to the breakout board and then plug this thing into the Game Boy, which on one hand means that, yeah, the Game Genie is now dangling down the back, but you could also use a much longer ribbon cable there and simply place the Game Genie on your desk and then play the Game Boy without the cartridge and the Game Genie anywhere near it. And yeah, just being restricted by a bit of a cable down there. Yeah, but yeah, still, this is mechanically awful. Okay.
Okay, next one. How sturdy is the connection to the Game Boy? I'm not sure if this question is referring to the stability, sturdiness of the logic. So keeping up with the clock of the Game Boy and emulating everything. If this is the question, then refer back to question number 1, because yeah, that's the long list of games that are supported or not. If they're working, then there is no problem of the Interceptor falling back usually. It's using a microcontroller, not an operating system where maybe a background task starts and suddenly it cannot keep up. It works very reliably. Once there are no bugs or there is nothing special done by the game which trips the Interceptor, then the logical part works very reliably. If you're asking about the mechanical sturdiness, this depends a lot on the case that you build for the Interceptor. I personally prefer the one with the reproduction shell, simply because it's very easy to build, it's lightweight, and it's also easy for me to open and test new firmware on it, in contrast to the more massive 3D printed one, which of course I have here. Yeah, there it is. So this one, I don't like that much because, yeah, you really have to unscrew the entire thing if you want to check new firmware. But if you do not update the firmware that often, this one, of course, is much more reliable. And I never had a problem with the connections. I mean, I'm playing a lot with the Game Boy camera, and that works fine, and that's already quite heavy. Of course, if you're using the game Genie on top of the Interceptor, that might be a whole different story. Next one. What is the output latency if you have a way of measuring it? Actually, in my videos and everywhere on social media, I explained that the Interceptor is not designed for live playing. It's designed for recording and streaming. Because anytime I tested it, there was definitely noticeable latency. However, I've seen some people playing on it in a way that looked quite well, and they also told me that it was working quite well. And I think that the main source of latency actually comes from the USB driver level. The Interceptor itself has 1 or 2 frames of latency. That's because every time a frame of the Game Boy finishes, the Interceptor pretty much finishes at the same time, because that's the way it works. It cannot work differently. But it then copies it to another buffer that stands by for the moment that the USB video class actually requires the next frame. That has to do with the way Tiny USB supports video, so we do not have dynamic frame rate, but we have a fixed frame rate, and therefore it can take up to the next frame when USB actually picks up the new frame. So it's 1 to 2 frames latency in the Interceptor itself. The problem is that I think there's additional latency in the video driver on the operating system level. I have done not much research, but I couldn't find anything definitely how much is coming from there. And finally, the host software can also add some latency. For example, if you run it on VLC on Linux, it starts with a default buffer of, I think, 300 milliseconds, simply because it's usually used for some streaming device and doesn't want to stutter once there's a little delay in the transfer. But you can turn this one off. So it quite certainly depends on the combination of the operating system and its USB driver or USB video class driver and the host software. And we can actually measure it for you. I will turn this camera into 1080p and 120 frames per second. That's twice as many frames as the Game Boy does. And so we can simply put the Game Boy next to the screen and test a few different combinations. Since the latency does not depend on what's shown on the Game Boy, I decided to use the simple example of the switch in Tetris between the credits and the title screen. On Linux, using VLC, I get 18 frames, that's 150 milliseconds. With OBS, I get 13 frames, that's 108 milliseconds. On Windows, using the native camera app, I get 9 frames, that's 75 milliseconds. With OBS, I get the same 13 frames as on Linux, that's 108 milliseconds. And on macOS, with VLC, I get 24 frames, that's 200 milliseconds. And with OBS, I get 18 frames here, which is 150 milliseconds. And I would estimate that there's an error of about 3 frames here, which is 25 milliseconds, because the flickering screen of the Game Boy is not even that fast. Also, remember to turn off any caching if you want to have low latency, as you can see here from the comparison of VLC on macOS. So next, Interceptor, Inter-Interceptor, 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 let's call it Interception, okay? Yeah, we can try this. I only have 3 interceptors ready, the ones from the video. So the big 3D printed one, the one with the minimal case, and again, I have to search. And there it is, the one with the cable, which I used to demonstrate that different shaped cases are possible as well. So I hope you are satisfied if I only show you 3 interceptors in the Interception. I will build this monstrosity in this corner between my laptop and my PC, and you will see later why I do this. So let's start with the Game Boy Color that we used before. Then I have this interceptor over here. So let's put it in. Then I have the interceptor with the minimal case. So yeah, I would stick to the 3 interceptors that I built for the video. I think that's already enough. Then what else do we have? We have the one which I used to demo the breakout board. So let's put this in there as well. Seems to be okay. And finally, we will put the Game Boy camera at the end.
So let's move this up and then plug it in as well. And yes, this is totally viable, isn't it? First thing to test, if the Game Boy camera still works through the entire thing. You cannot really see it, so let me turn this a little bit. But here you already see the screen. And I don't think there's a way that I get my head over there. So it's only looking at the at one of the lights, actually. I can move my hand over here. Hi, that's me waving. So this is still working. But we also have to check if the interceptors work. Although if you think of how the interceptors work, you could now imagine that the signal is going through all of them. So they should be able to stream the video. But that's where building this in the corner comes in. Because if I just hook it up to a USB hub to my laptop, it will not work. And the reason for this is that the interceptor only uses the USB interface of the RP2040, which is a USB 1.1 interface, which has quite a limited bandwidth, which is also the reason that the interceptor can only do 29 frames per second. And at that point, you might now think, well, that's not a problem because I've got USB 3 with plenty of bandwidth, and so I could handle several of the interceptors. But the problem is that's not how it works. First of all, USB 3 usually is handled separate from USB 1 and 2. Those share a bus. And nobody cares that this is only small bandwidth. The important thing is that the interceptor uses up a lot of the time that the USB bus can communicate. It is not efficient during this time because it's only USB 1.1, but we're using almost all the bandwidth of USB 1.1. Actually, we're using all the bandwidth of USB 1.1, which means we use up all the time the USB bus has to communicate with this. So you cannot use two interceptors on a USB hub. Actually, many people struggle using the interceptor with any different device on the same bus as well. And this means that since my laptop only has two USB ports, I cannot hook up all three of the interceptors to my laptop, which is why I moved to the corner. And I will hook up two of them to the laptop and one to the PC. So give me a second to arrange this. Okay, I know I will not win any award with this image composition, but I got all three interceptors hooked up, and as you can see, they're running. Let's go into the camera view to show that they're actually working. Yep, so again, no, where's the camera? Over there. So that's me waving over here. And yeah, actually the only way to see that these are different interceptors on each screen is if I change the mode of the interceptor with the mode button. So obviously, now I turned this to green. This one over there at the laptop on the right-hand side is this interceptor. Then this interceptor will be the one on the left-hand side. Where's the mode button? Should be down here. Yep, blending, and there we switch to green. And yeah, I'll probably lose the connection if I try to reach the button of the first interceptor for this one here, but let's try, because yeah, that's not stable anymore. But mechanically speaking, yeah, I can do it. Okay. Yeah. So yeah, it's working. But of course, it doesn't make any sense in the first place to do this, of course. But you should keep in mind that the USB of the interceptor is not playing well with other devices, so you will not be able to hook them all up to the same PC. And one other thing that I noticed when I tried to turn on the Game Boy, it did not want to do so while all USB cables were connected. I'm not entirely sure why this is the case. I suspect that there might be a difference in the ground potential between the PC and the laptop. Although that's running on battery right now. I'm not entirely sure, but I had to disconnect the USB to turn on the Game Boy, and then I had to plug it in. And yeah, in any case, nobody really wants to do this, but Interception working.
Next one. Is it possible for the GB Interceptor to output through HDMI instead of USB-C? I don't know if it's USB 3 already, to output full 60 FPS video to the computer. And I put it together with the other question, what would be needed to make it run at 60 FPS? Pretty much the same as the second half of the first question. Okay, first of all, as I explained while we did the interception, The Interceptor is only using the USB interface from the RP2040, which is USB 1.1. Which means that the reason that we cannot do 60 FPS is actually the bandwidth of the USB port. So putting HDMI after this will not help. And it's a combination with the video formats that are supported by the USB video class, or which are widely supported. However, in theory, you could, of course, create a device which supports a more exotic color format and then creates an output via HDMI. I don't think that makes that much sense, but what I'm thinking about doing, despite, of course, the option of adding USB 2 to the device, that might be something where you have to redesign the hardware. Another option would be to output the raw data in the format that the Game Boy uses. So instead of NV12, which is the color format that we use, which is the most compact, uncompressed color format that is widely supported by the operating systems, which uses 12 bits per pixel for color information mostly, which we don't need. Instead, we can output, of course, a format with only 2-bit color information, color, because that's the bit depth of the Game Boy. 2 bits equals 4 colors, or 4 shades of gray, or 4 shades of green. And instead of using the USB video class, which does not support this, we can simply output it in our own format. But this means that we cannot simply plug it into any computer and just run it through any webcam software, but instead we would need additional software on the host system. I'm thinking about writing a Python script which can take this 2-bit data stream and then create a virtual webcam, like some of you might know from OBS, and then you can put this into the system. So the difference would be that instead of just plugging it in and popping up like a webcam, you would have to run a Python script, and that will then create the webcam, and you should be able to get 60 FPS through this. Should, because I haven't tried it yet. And yeah, I hope that I can start looking into this in a few months. There's another project that came up and has a very near deadline, which I first have to look into. But after that, I want to try this to give you the 60 FPS eventually. Okay, the next one fits in quite nicely because that's the question about Mac support. So will there be Mac support in the future? First of all, there already is Mac support in some sense. I should explain that when we're using the USB video class, or the reason that I use the USB video class is that it should be independent of the operating system. USB video class is well standardized. You can take any webcam nowadays, plug it into any computer, and it should just work if it's a USB video class device, which most of them are today. And it is like that right now. I take the Interceptor, plug it into my Linux PC, and it works in all host software that I can think of. I can use it in Zoom, I can use it in VLC, I can use it with FFmpeg, I can use it with, I'm not sure what else I tested it. No matter what I tried, it worked. I can plug it into a Windows PC. That's not a Windows PC, I don't have a Windows PC. And there, it's also recognized as a webcam, and it works in most of the software that I tried, except for VLC. I'm not entirely sure about this. There comes another detail into play, that, of course, the video format that the Interceptor uses has to be supported by the host software. I'm not entirely sure if some of the drivers, like on Linux, where I have no problem whatsoever, does some of the conversion. But the point is, as we're using this NV12, because 12-bit is much smaller than the alternatives, this is, I think, an older and somewhat more exotic format. And that may trip up some of the software that has to interpret and show the stream. I'm not sure why VLC has a problem with that, because usually VLC has no problem whatsoever. But that's the one example I know of on Windows where there is a problem. I can plug the Interceptor into my Android phone, just via USB-C. I mean, it's a USB-C plug. That's the nice thing about USB-C. And you have to look for an app that supports external webcams. There are several. Most of them do not support NV12. Some of them explicitly tell you I cannot do it because of the color format. But there's at least one example, which I also mentioned in the wiki, where I've got a compatibility list about supported host software, and it runs on the Android phone. And if I do it on the Mac, actually, if I do it on Intel Mac, an older MacBook Pro, in which I tried, and I've got some samples, I think, from 4 or 5 people who reported back that it's working on their Macs, it works the same. You plug it in, and you can use it in FaceTime, you can use it in this webcam, I'm not sure what it is, photo booth. Photo booth? Is there an app like that on a Mac? I'm not sure. But it works on this one. And it works in VLC. It works in OBS. It works with FFmpeg. It works with anything I tried there. And it works just like on my Linux system. Perfectly. Yeah. But if I try it on an M2 MacBook Air, and I think I've got reports from about 10 people using M1 or M2 Mac devices, then it's recognized, but you get a distorted green image. And I actually also, since I could luckily try it on a MacBook, if I intercept, so that's not the interceptor, but actually intercepting data within the system. If I use Wireshark to intercept the USB stream that the MacBook sees, then the entire stream is intact. So you can see all the data that belongs to a single image. But if you then push it through FFmpeg, record from there by telling FFmpeg to not touch the stream, do not change anything, then you only see every second line, only the data that corresponds to every second line. It's like it's deinterlacing, but on a data level. That's the really strange thing about it. It doesn't make sense to deinterlace it like that because it's in NV12. We first get the grayscale data, then the color data. And if you want to deinterlace it for whatever reason, because the interceptor is not claiming to show an interlaced signal. Yeah, but if you would deinterlace it, it still doesn't make sense to only erase every second line. But it seems to be something that's done on the M1 or M2 Mac on a level of AV Foundation. That's the framework for the video stuff. I cannot rule out that there's something strange with the interceptor because many webcams work on the on the MacBooks. So quite certainly there's something special about it. I mean, it starts with having a resolution of 106 by 144 and then using NV12. That's certainly a combination. And then 29 frames per second also is not the usual thing. So maybe some of these combinations, maybe something, the way it communicates via USB, maybe it's not correct to do this way. But quite certainly, after it's running on Linux, Windows, Android, and the Intel Macs, at least there's an inconsistency at the end of the Apple driver, and I have no idea where it is. I already filed a bug report with Apple, and of course, I got only crickets. So this project is not interesting enough for Apple to even reply. Not sure how this usually works. So yeah, I have no idea. So the answer is you shouldn't require specific support for a specific operating system. It works on Intel Macs. I have no idea why it doesn't work on M1 or M2 Macs, but there's the good news in here. What I explained for the previous question of using a Python script to get 60 FPS on the device, I'm quite sure that this would also work on M1 or M2 Mac because it does not require the video class. It doesn't require AV Foundation, at least not for the camera part. So it would just require you to set up a Python script. So once I got this working, I'm quite confident that it would also work on a Mac. Or also work on the M1 and M2 Mac, because as I like to emphasize, it's already working on the Intel Mac for, I think, since version 1.02 or something like this. Okay, next one. Combining this with your last project, is it possible to capture things you stream onto the Game Boy? This refers to the Wi-Fi cartridge. I mean, probably most viewers have seen that one because YouTube again boosted the Wi-Fi cartridge after I released the GB Interceptor, and the GB Interceptor video got a lot of attention in the retro gaming community. But looking at the total of YouTube, the Wi-Fi cartridge got much more exposure again. So let's search for it. There I got 2 copies, and yeah, let's try this. The setup is easy. Problem might be that electrically, this probably gives us some trouble. Let's see. Oh yeah, that's starting great. Yeah. Okay, nothing here. So the problem is that I should have prepared with a few fresh AA batteries. As I mentioned in the Wi-Fi cartridge video, it draws quite a lot of power. It's glitching all over the place here. So the Wi-Fi cartridge draws a lot of power while it's connecting, and the Game Boy cannot really keep up with it. And that's why you see these glitches. And during these short reboots, sometimes also the interceptor then cannot follow anymore and hangs. And this means that I probably need to try a few times until I get it to work. And for another try,
Oh, you can almost see the Nintendo logo. Let's start the stream. Come on. Ooh. Okay, it's not yeah. Okay, that looks good. Yeah, okay, the movie is actually working on the Game Boy. And the Interceptor is recording too. Okay, we finally got it. Yeah, I decided to show you the start of a movie that I highly recommend. If you can already recognize it, then that's good for you. Everyone who doesn't recognize it should probably watch it. Yeah. So one thing to mention is that you now have to put up with the old Game Boy's screen at this point, because the current code that I have on the Wi-Fi cartridge for streaming actually has support for the Game Boy Color. So if I try it in the Game Boy Color, it goes into the color mode. And as I mentioned before, the Game Boy Interceptor does not support this. I would love to do this on the Game Boy Pocket, but the Game Boy Pocket, despite having the nicest screen of them all, has the worst voltage converter, and there is no chance to start this with the Wi-Fi cartridge. So you have to put up with the old school Game Boy again. Yeah, but besides that, the setup is quite simple. I'm streaming from my laptop to the Wi-Fi cartridge, and yeah, I'm recording also on the laptop, so that's quite a loop there. But yeah, you can intercept the stuff that's coming from the Wi-Fi cartridge. Only problem is that you have to get it running first because of the voltage glitches that it has. Okay. Yeah, and I think we're at the title screen now. Yeah, so that's the movie that I recommend. Not the newest one. Most of you probably know it already, but it was just one thing that popped into my head to demonstrate. Okay, I think that's enough then.
Next one. What happens when you plug it into a Super Game Boy? Does it work with the Super Game Boy? Unfortunately, I don't have a Super Nintendo anymore. I sold it long time ago, and I really regret selling it. So I don't have a Super Nintendo, I don't have a Super Game Boy, but I got reports back that it works. And actually, there's a live stream from RetroBreak. I, of course, link to his channel in the description. Who tested it in a long session of testing the Interceptor. Warning, if you look into this, at the beginning, many games failed because they were Game Boy Color games. I said they are not supported. Later on in this video, the Interceptor worked much better, and he was trying it on the Super Game Boy, and it seems to work nice on it. And by the way, the same goes for the GameCube Game Boy adapter. Next one. Can functionality be triggered by reading data from a specific memory address, like changing the video output based on what's happening in the game? Yes, I mean, in a certain sense, that's what the Interceptor does. I mean, it changes what it shows depending on what's happening in game, but that's not what you mean, of course. It's not implemented at this point, but it is quite easy to implement a certain code that is triggered whenever a certain address or a certain branch is taken by the Game Boy game. Actually, I use this to fix some of the games. In the main video, I already discussed that the Interceptor cannot see the gamepad input, and there are some edge cases where the game does something, takes the data from the input and directly uses it in VRAM, which we cannot take. And actually, the fix I do there is that I use some later point in the game where the code branches, depending on what you pressed, to retroactively fix the data that the game used before without branching. For example, you could easily program something like that the colors of the output change at some point. I mean, we've got this retro green mode and the grayscale mode. We can change this at a certain point. Something that might make sense is to turn on or off frame blending depending on which level or which part of the game you're in. Because the flickering effects that you have got on many older Game Boy games do not come across great at 29 frames per second, but they look much nicer if you use heavy frame blending. But in other parts of the game, this heavy frame blending might look like a trail behind moving objects, and you might not want it there. And so, for example, you could trigger that at certain parts of the game it's turned on or turned off. One thing that I have on my to-do list, but I'm not sure when I get around to do this, is actually a timing function, so that the Interceptor notices when you start a level and it counts the number of frames until you see the game over screen, hopefully because you won, or maybe it's a game like Tetris with an open end, so to say. And that, of course, also something the Interceptor would show depending on how the game branches. So this is totally possible. Just depends on how you implement it or what you implement. Then, can it reproduce the effects in the game of Prehistorik Man? I have to admit, someone suggested this game as a test before, but I haven't tried it yet. So I looked into it now, and I have to say, this game rocks. I mean, the game itself is, yeah, but what they do with graphics is amazing. So let's see what Interceptor does with it.
Okay, welcome to Prehistorik Man. Don't be confused by all the stuff you're seeing right now. What I'm doing to demonstrate this is I'm using the emulator Emulicious, which you can see in the top left corner here, and a bunch of debug output from the emulator to explain the effects that we're seeing, because I want to explain why things work and why some things don't work on the Interceptor. And in the bottom left corner, you see a recording of playing the game on a Game Boy Color and intercepting it. So I can pause it and actually discuss this stuff, because on a real Game Boy I could not pause it at every moment I would like to. Okay, so let's start. I will explain the debug output as we get to it. Okay, so let's start. So here's the first effect, something that you can see on several games actually. Let's pause it at this moment. So this wavy logo. So if you're not familiar with how the Game Boy works, the Game Boy creates everything on screen from so-called tiles. So that's what you see in this image. So this is like a collection of stamps that you can use to create the image. And on the right-hand side over here, let me just pick the right setting. This is called a tile map. This is where all these different tiles are put together to form an image. So if you look at this S here, then the emulator should highlight it somewhere. Yeah, over here, this part of the S is over here. This part of the U is over here. And so all the tiles are assembled to form the image, and that's called a tile map. An important thing about the tile map is that the actual tile map is actually the entire large white square here. Most of it is not used during the logo, but a feature of the tile map is that the actual screen of the Game Boy is much smaller, so only this part, and you can set a scroll position to select which part of the tile map is to be shown as the screen. Usually, most games only move a square around on the tile map, so to zoom to scroll within the map, for example. But what this game does, and several games do this as a logo animation, it changes the position, the scroll position, for every single line. So the Game Boy draws the image line by line, and for each line, it changes the horizontal scrolling position of the part that's visible of the screen map. And the emulator shows this with this dotted wavy line over here. So this is the position for each line that was selected to be shown on screen. And if I continue, as you see, this is what's animated and which shows up as the wavy part, and it gets straight. Then the logo is straight again. These types of effect usually work nicely on the Interceptor, at least as long as the Interceptor is synchronized to the Game Boy properly. So yeah, as you can see here, logo works out nicely, and it gets straight in the end. Let me pause at the right moment, like this. That's usually not a problem for the Interceptor, as long as it can synchronize its emulated graphics unit to the real graphics unit of the real Game Boy. I haven't looked into the code here, but it does this by default if there is a VSync interrupt that it can use, or if it recognizes a tight loop waiting for a specific status of the stat register, for example. So this part works nicely, but that's not too specific. That's not the reason why you have been asking for Prehistorik Man. Let's move on. Then here's the title screen, and there's so much going on in this game. just let it sink in. First of all, okay, now let me pause. One part that I like about this game is, or this title screen, is how they work with the clouds. I just like it. It's technically not that surprising, but what you see here is that the clouds all move at different speeds. That's a typical parallax effect that you see in many games, although you shouldn't call it parallax while the camera is not moving. If clouds are all moving at the same speed, but at different distances, then this is still a parallax effect, I would say. The thing that's slightly unintuitive is that the clouds in front can move in front of the text, and the text is still in front of other clouds in the background. And that's simply done by a good arrangement of the graphics, because if you look at the tile map, you see the word prehistoric as part of the tile map, but the word man is not. And below that, you see the clouds, and the clouds at the top part are missing too. And if I continue playback, you can also see how the clouds move at different speed, because again, the scroll position is changed for these lines, and for different layers of the clouds, they change at different speeds. So that's something you see in many games. But what's nice about this arrangement is that the word man is actually added as a sprite. Just let me pause when we can see it. So sprites are what is usually used for anything that moves freely on the screen, because the tile map has to align all the tiles in a grid. So it would be really tricky to move a player with this, unless the player can only jump by 8 pixels every time. So instead, what the Game Boy also supports is so-called sprites. Actually, on the Game Boy they're called objects, but I call them sprites because that's a more common name today. Which means these can be, again, tiles that can be placed freely on top of the background tile map. And in this case, the word man is freely placed at this part in front of the clouds, and another set of clouds is freely placed in front of the word prehistoric. And this gives this effect. Yeah, I just like it. It's not that relevant for the Interceptor because that works nicely on Interceptor. There's not technically not something too fancy. So let's talk about the elephant in the room, the thing that I think that's the signature effect of Prehistorik Man. The one thing that fails on most naive emulators. This is the text in front here. Actually, we're just beyond the text. So let's reset and have a look at it again. Yeah, let's skip this title screen. There's text again. Because if I pause here, you won't find this text in the tile map. You won't find this text in the sprites. The text isn't there. What's happening is the game changes the color palette within the scan lines. So first of all, what's the color palette? These tiles here already come with 4 shades of gray, at least it looks like it. But for each of them, if you create a tile map, then you also set a color palette, like the one down here, which assigns each shade of gray the actual shade of gray that's shown on the screen. So for example, I can disable this auto palette thing, and it uses a default palette now. All these colors can be mapped differently. And there's a different color palette for the background tiles and for the sprites. So the same tile can look differently on in the background tile than as a sprite. And you can do some interesting effects like let the player flicker with different colors. Actually, creating different players, player 1, player 2, from the same sprite, but with a different color palette. So one of them has a gray shirt and one has a lighter gray shirt, for example. We don't really have colors here, but shades of gray. What the game now does is it doesn't change any of the tiles or anything, but while the Game Boy is rendering it line by line, it does not only change something between each line, but within the line, it changes the color palette one by one. And this is really tricky because you have to have exact timing there. And there are some limitations to this because the Game Boy always picks 4 pixels at the same time to render. And you cannot change the color palette in between these 4 pixels, which means that if you look at if we animate this step by step, these letters can only move by 4 pixels. So I think at this edge of the E, is it the E? Present? Yeah, in E, we can easily count this off. So 1, 2, 3, 4 pixels is 1, 2, 3, 4, the edge of this palm tree. And if I skip by 1 frame, It's at this exact edge, okay? So the right to left movement is always by 4 pixels because that's the maximum precision that you can get with this method. Yeah, and that's what the game is doing here. It's a very creative idea to use the ability to change the color palette, and technically the timing is impressive. So what does the Interceptor do with this? So let's continue the video. So good news, the clouds are working nicely, but the font is entirely glitched. And the reason is that at the moment, the Interceptor does not really care about these details. It applies the color palette whenever it changes, not only for these 4 pixels. At least I think so, not entirely sure. And even though I know about most of the timing details of the individual scan lines, because the pen docs are very detailed about this, I do not implement them because that would be in vain. The problem here is that we cannot get this type of precision on the Interceptor. The way it currently works is that it has 2 CPU cores at its disposal. One core entirely is dedicated to emulating the Game Boy CPU, and yeah, there is no headroom left to do anything else. And the other core is actually rendering the image. And of course, we could have a higher precision there, but the problem is this core also deals with the USB communication. And since we are in isochronous transfer mode on USB, this means that the USB bus dictates specific moments when we have to deal with things on the USB bus. And the host PC does not do us the courtesy to synchronize to the Game Boy. And even at the moment, I can output timing of the screen rendering for debugging purposes. And what you can see there is that some scan lines take much longer than they should, because some stuff going on in the USB bus interrupts them, and the core shortly has to handle a few things there. And unless there is some more efficient implementation that I don't know of, there is no way to get this precision, simply because the core has to deal with the USB bus as well. So it doesn't make much sense to try to improve the timing there. So instead I go for efficiency for each line. This means that any game that does effects within a scan line will not look properly. Luckily, there are very few games that do this because it also requires insane timing for the game. And usually that's not compatible with actual gameplay at that point. So you will mostly find this type of effects in title screens, stuff going on between the gameplay maybe, and demos. But if something like this occurs, that will not work on the Interceptor. So let's continue for the next effect that I really like, because I mean, you probably asked mostly about this effect, but there are some other things that I really like about this, the graphics stuff that the game does. So after the font, come on, we're waiting. Yeah, now it goes on. We get this nice scrolling effect, and with so many layers. I mean, I've rarely seen anything on the Game Boy that gives you this idea of depth, because first of all, there's still the clouds going on that I mentioned before, but then the palm trees are moving in front of these bushes at a different speed of the background. Actually, this part, the bushes in the background, is something that you see in many games. This little parallax effect in the background. If you look at the background tile, you see the mountains and the far palm trees and the bushes in front, and you could simply see these lines from the scrolling. The scrolling is simply done at different speeds. Also the floor in front. Yeah, so that's something that you see in many games. When you see parallax effect, usually it's the same. And on the Game Boy, usually this also means, because it only has one background tile map, that the graphics do some kind of trick, like here, that the background is just horizontal lines, so you cannot see anything overlapping. So the bushes will never overlap with any aspect of the background that should scroll in a different speed, because the Game Boy cannot do this. Yeah, except for the palm trees. The palm trees actually overlap with the background, and that really conveys this effect. How is this done? Well, if you look at the top of the palm trees, then you can see them showing up here. Not at this moment. Yeah, at this moment. Just as an explanation, so the sprite view here changes a little bit because the game switches the sprites halfway through the screen. So sometimes you see the clouds and the man, and so the word man, and then you see the palm trees and the guy that's flying there. And the emulator, seems to make a snapshot at a random moment, so it's glitching between both parts that the game uses. But if you look at the palm tree tops, that's just a sprite, and it's moving here, and the sprite is drawn on top of the background layer, so it can easily cover the background that's scrolling at a different speed. But the trunks of the trees are a little bit surprising, because if I pause at the right moment, they overlap with the guy flying in a different direction and at an entirely different speed. So if you are new to the Game Boy, it might not surprise you, because if you look at it, you see, okay, the guy is a sprite. So here's the glider, and the guy is at the bottom of this. And the trunk of the tree is also a sprite. But what you need to know is that there is no parameter that orders the sprites. So there's no way to determine that one sprite should be in front of all the other sprites, but instead the Game Boy always renders the sprite in front that comes first. So yeah, it renders it from left to right. So the first sprite looking from the left is the one in front. And that means that if two sprites overlap, then they start to flicker if they move across each other. Or actually, at least they change the order at the moment they cross. And since the guy is made up of, I think, 1, 2, 3, 4, 5, 6 sprites, it would be more like flickering, because each of these sprites would move in front of the palm tree as soon as it's slightly to the left of the palm tree. And the way the game avoids this is, if you look now at the trunk while it's moving, in contrast to the tops of the tree, these trunks are shaking. And the reason is that in contrast to the tops of the palm tree, they are not moving freely pixel by pixel, but they're jumping in steps of 8 pixels. And then within these 8 pixels, they get animated by picking different tiles with different positions of the trunk. And the reason the game does this is it can achieve the following. Now I highlight different sprites at the bottom, and as you can see, the emulator is marking them at the top left. So have a look at the top left. These are sprites from the guy. Okay. And now let me pick the trunk. These are the 2 sprites from the trunk. So the corresponding one from the guy would be these 2. This is the guy. This is the trunk. So they are in exactly the same position. And the reason the game does this is if they are in the same position, then the one that's first in the sprite list is drawn on top. And this way the game can achieve that the palm trees are always on top. And there's one more thing going on. There is this card that's dragged in. This is the window function of the Game Boy. So the window is just works the same way as the background tile. So it has a tile map. It can use a different tile map. So let me switch over here. This tile map. Here are the cards that are dragged in. And the interesting thing is that for the window, you simply define just the top left corner, and it's always drawn entirely to the bottom of the screen and to the entire right of the screen. You can prevent it from drawing it to the bottom by simply disabling the window halfway through, but you can never prevent it from drawing it to the entire right, which is why the guy never pulls the card so far that you could see to the right of the card. This effect is just amazing. Yeah, I love the result. I love how everything is composed, and it really gives a lot of depth for a Game Boy game. Let's have a look at what the Interceptor makes of this. So let's just jump forward in the video. So palm trees are working nicely. There's the guy, there's the card, everything is fine. Little warning there, if you're trying this at with the current version 1.1.0, the cards are messed up. The reason is that in version 1.1.0, I made an adjustment to how the window is rendered to fix a problem for games that turn off the window rendering within the frame. What I did not realize until this point, and I think that's one of the things that are not that well documented anymore, this fix only applies if the window is turned off during the during a frame, not if it's only turned on during the frame. And that's what's happening here. So with version 1.1.0, I broke it. And what you're seeing here is my current development version. So with the next release, these cards are fixed as well. Okay, so let's move into, no, not into the game. Next effect. So let's press start. Oh yeah, there it goes. And another surprising effect for the Game Boy. So we've got more or less a 3D perspective, and there's text, scrolling away from the camera under the guy flying in front of the parallax clouds. I mean, clouds work the way we would expect by now, but then there are these letters. So let me shortly pause. Okay, I know why. Let's move on a bit. Yeah. So this is the tile map of the background. Let's disable the currently used palette for now, because it's changing all the time, as you will hear shortly. So that's the background. You don't see any text in here. These are the sprites. No letters in here. On the tiles itself, you don't see it anyway. Of course, if I start and pause again, at the right moment, the guy is a sprite, but that's exchanged halfway through the screen. The clouds are the same parallax effect as before. But how are the letters drawn? So what the game does here is it uses, again, the color palettes, but now in a different way. On the floor, you have the same uniformly colored background, so this white color here, and you've got these 3 beams, I would almost call them, in 3 different shades of gray, which form this perspective. And what the game now does is, on each scan line, it maps them differently. First of all, it maps the white background to white and light gray alternately. So to give you this perspective of movement, because otherwise this would be uniform and there would not be any motion. So it simply changes every other line, that white color to the light gray. And then what it does is it picks which of these 3 other colors are mapped to black. Either one of them or multiple of them, and the other ones are mapped to the same color that the background is mapped to. So for example, at the bottom of the M, that's an M, is it? That should be an M, yeah. It decides that the white background is this light gray, because that's, just the part where it's a light gray. Then the light gray is mapped to black. The medium gray is mapped to white gray, like the background. And the black part is mapped to black again. So this part here has the outermost beams active, so to form the outermost parts of the M. In the center, all 3 are mapped to black, so that the middle part of the M is also black, and so on. Only problem with this method is, how do you do, for example, this N. Actually, there were other examples, but this N is more obvious. We don't have the beams in between. So we cannot color these parts differently because I have the same color as the background. So how does it color in the black part? Well, again, it uses sprites. So if I move over this and you look at the image over here, you can see the entire thing is covered with sprites. So these sprites form up the other 2 beams. And since the sprites have a different color palette, it can also set the color palette of the sprites individually. And this allows to set these to set black on these 2 other beams as well. So this is how this effect works on the Interceptor. Let's move in. This works quite nicely. There's some glitching or some noise, I would almost say. It looks noisy to my eyes, because the individual scan lines are not perfectly synchronized, and the palette change is sometimes happening within the scan line, which especially makes the farther away lines a bit more noisy, but in principle, the effect works okay, I would say. So, okay. Then, as we enter the game, are we in sync? Almost. Unfortunately, we get the text effect again, and that one, come on, game, do it. That one is in changes within the scan line, and it absolutely glitches, of course, just like the title screen. But then there's the game again. Oops, the video is going on, or why not? Yeah, and the game works nicely. Unfortunately, I'm a bit underwhelmed by the game after seeing all this, because it's just a mediocre jump and run game, and I fairly suck at it. I cannot say that there are not any more fancy effects in there, so let me just pause it at the moment. There are some more effects, but they usually work, they seem to work on the Interceptor. There's some amazing things that the game does work around some limitations of the Game Boy. If you want to learn about these, I learned a lot about the graphics of this game from a blog entry by Eldred Aber. I will link to it in the description, and he also talks about a few more details of what the game does here, a few more details of what the game also does on the credit screen, and even more details of stuff that I quickly went over here. If you like this kind of stuff, really look into this blog entry. It's amazing what this game does. So it's a little bit disappointing that the game itself is not that great. Or maybe I haven't played it long enough. I'm not sure. Oh, by the way, he also explains that the credit screen also does some fancy rotation effect, which also relies on mid-scanline changes. I haven't played the game to the credit screen, so I haven't checked it, but I'm quite sure that this will also glitch on the Interceptor. So, as I said, anything that changes within the scan line is a problem. And if you try it again on the current version 1.1.0, you have a moving scan line on the image of the normal gameplay. That's because in the current version 1.1.0, it cannot find a way to synchronize in the main game. As you've seen from the recording here, with my current development version, this is fixed. So yeah, with the next release of the Interceptor, there should not be a problem with this anymore. Okay, and I think that's enough about Prehistorik Man. So at that point, we get to what I call the meta question. So let's start with the first one. When will you sell me one? I won't. Next one. No, seriously. I do not sell anything, any of my projects, not anything at all. That's because I'm doing this because I enjoy creating projects like this. I enjoy puzzles like solving the problem of interpreting the data from the Game Boy and reproducing the image, stuff like that. And I like talking about this and presenting my work, but I do not enjoy selling things, customer support, taxes, certifications for electronic stuff, and all the legal stuff behind this. Of course, logistics, and that, of course, returns and things that have to be fixed. I'm happy to help anyone who reached out to me with his new Interceptor, and any problem can testify that I'm usually happy to help. But I don't like to be obliged to do this. And if I have other stuff to do that's more pressing, or if some question is really stupid, if I may say this, I like to have the right to ignore it. And after all, this is only a hobby that comes after my family and after my day job, and only in the time in the evening when I have some time left for this. And I don't want to also start a business selling stuff, having to solder all these things or order all these things, storing things, selling things, and you get the point. I'm not going to do this. But I made sure that the open source licenses that I use allow others to produce the GB Interceptor. And I've heard from several who are interested in building them, either just selling a few spare ones, also intentionally building more of them to sell them on some retro gaming store. And I do not object to this. So if you do not want to build it yourself, I mean, I've got a precise video on how to create them, which hopefully is not too difficult for most people. But if you want to build a finished product, you should be able to find some at some point. You're just not buying it from me, you're buying it from someone else. So you will not get extra treatment from me just because you paid for the thing. So as usually, I help if I can, but it's not my responsibility. Next one. Where did stuff get difficult? Okay. That's a
quite broad question. I think the first thing where I really struggled, or where I thought it might be not possible on the hardware that I designed, was for the first time I could not keep up with the Game Boy clock. The funny thing is that when I got my first prototypes, I tried them, and they pretty much worked perfectly immediately, which is of course to some extent because I used the existing design from the Raspberry Pi Foundation about the minimal way you can use the RP2040, and I only added some bus transceivers to communicate with the Game Boy. As I said, I think in the video, the Interceptor is pretty much a Raspberry Pi Pico, but with outputs or actually inputs matching the cartridge design of the Game Boy. So that worked almost immediately, except for 2 LEDs that I designed the wrong way around. But yeah, something has to go wrong. And I uploaded my first test code using the programmable IOs to get the data from the data bus, and it worked perfectly, and it was easy for the Raspberry Pi to keep up. Then I tried to actually look for the start of the game. So this address where I noticed that after turning on the Game Boy, the bootloader has finished and I'm starting the game. And the Interceptor missed it almost every single time. And it looked like I was missing bus events. And it took me quite a long time, an embarrassing long time. But I'm learning stuff from these projects myself to figure out that it was because by default, the code on the Raspberry Pi, or with the Raspberry Pi Pico framework, is running from flash memory. And flash memory is way too slow, but I didn't notice it in my first tests because it has a caching function. So once the code runs through, it's slow the first time, but after that it's running from cache, which is pretty much as fast as RAM. And then it runs fast enough so that on my test it looked like it is getting every single line or every single bus event. But then when I try to do specific code that starts once I've got a specific line, it's reading from flash again because that code wasn't executed before. It was way too slow. And this is a problem that came back again and again. Not the problem that it's running from flash, but the problem of keeping up with the CPU, because it felt like every time I did something new and I added a function to the Interceptor, I got the problem that I could not keep up with the CPU and I had to tweak and fix everything again. I mean, in the end, I had to overclock the RP2040, which is something that hopefully can be improved at some point. But details like noticing that interrupts are a problem, that I cannot easily predict when an interrupt occurs, but I can only realize that the interrupt occurred in hindsight. So I had to implement a read ahead function so that I get the next bus events before I interpret them. And that, again, created so much overhead that I could not keep up and stuff like that again and again. So this is usually the thing I struggled with most in this project. I hope this somewhat answers the question. Next one, what would you do differently? Looking back on the project, what would you have done differently, if anything? If I think about the most striking problem of the Interceptor, it's USB 1.1. I mentioned it before with the interception experiment, that often if you've got problems with Interceptor, it's because the USB 1.1 port takes up all the bandwidth, or actually all the time of a USB hub. So it struggles being on a USB hub. It struggles playing nice with other devices, and it's also the reason that I can only do 29 FPS, and it's the reason that also all communications of the Interceptor itself have to be absolutely perfect to get everything out of that USB 1.1 bus. So if I would do it again, or if I would change anything, I would probably try to figure out if there's an easy way to upgrade this to USB 2, so like using an external chip for the USB communication. I'm not sure what this all entails. I've never done this, but that's something important, I think. One could also think about increasing computational power, so we can also use the Game Boy Color, but that's difficult. One of the nice things about the Interceptor is that it's pretty much a Raspberry Pi Pico, and it is really cheap. I mentioned in the video that I produced 10 of them for $25 each. If you mass produce them, you might be able to get them down to $10 or something like that. And I don't think that anyone will mass produce them like that. So if someone starts selling them, don't hold them to that price, because that only applies if you really produce a lot of them. But it's cheap. And this makes sense if you think about the use cases for the Interceptor. If you've got plenty of money to throw at the problem of streaming your Game Boy play, then you can mod your Game Boy. If you don't want to mod that specific Game Boy, get a second Game Boy, mod this one, get a fancy device, an analog pocket or something like that, and you should be able to solve the problem. The appeal of the Interceptor is that it's a low-level device that you can build or buy for a few bucks, and that solves the problem without changing your Game Boy. But if it becomes too expensive because you put more processing power in there or something like that, or an FPGA, then I think in many cases this defeats the purpose. So I'm quite happy with this very simple minimalistic design and using all the capabilities of the RP2040. I was actually quite lucky that the capabilities of the RP2040 add up to just be able to do what I'm doing here. The only thing that I think I would change next time is to see if there's a cheap way to upgrade it to USB 2. Next, how did you get started with designing circuits like that? In general, that's hard to say. If you're thinking about just the electronic circuitry by itself, I had always some interest in electronics, even as a child, but I never really learned it. And for a long time, I only had the grasp of a physicist. I'm a physicist, so I have a basic idea of how resistor works, capacity works, inductivity works. And that's pretty much it, yeah. But I learned most of it through projects like the Interceptor now, but also earlier projects, starting with simple Arduino stuff, learning how pull-up or pull-down resistor works, just building onto this. If you're thinking about creating circuits in the sense of designing PCBs, I can very definitely tell you which my first PCB was, because that's one that can be found on my YouTube channel. My very first PCB is the one for the macro keyboard. This one over here, yeah, so you're not seeing the PCB, but for this device, that's one of my videos from 2 years ago, not sure, but that was the first PCB that I designed. And if you're asking like this, it sounds like you think the circuits that I design are something impressive. I don't think that they are. They should not be a role model, I think, because I'm learning a lot of stuff while I'm doing this. Every time I publish a video like this, I get a bunch of comments with suggestions what I could do better. Not rude ones, not case of that's all bullshit. It's not that bad, but some suggestions of things that could be done better. And I think there are better people out there with more experience with PCB design than me. So I'm mostly doing the basic stuff that I need for my project to get them to work. But PCB design definitely is my weak spot. Okay. I think that's all to say about this. Next one. Did you have a moment in your projects where you screwed something up so hard that you kind of wanted to scrap the whole idea? How do you deal with this kind of frustration? Well, I think there are two examples for that. So one is a project that I might be scrapping right now. So actually one that I started before the Interceptor. I then did the Interceptor first, mostly because I wasn't sure how fast the Tetris enthusiasts needed the Interceptor. And at the same time, I got stuck with this other project. And in the end, it's a very simple chip on a already completed PCB design, which I could not communicate with. Very simple I2C bus. I'm still not sure why it's not working, but I'm actually looking at the sunk cost fallacy at this point. And I think I will give it one more try, soldering one of the chips that I still have on one of the PCBs that I still have. And if I still cannot communicate with it, this project is not interesting enough to really continue with it and design a new batch of PCBs at that point. So, at this point, it's just being realistic and seeing that I should not continue this path. But then on the other hand, another example for the Wi-Fi cartridge, the very first PCB that I created from this had so many flaws and so many mistakes. It was the first more complicated PCB that I designed. I mentioned before that my first PCB was this macro keyboard. I think there was the smart doorbell in between. And I think after that, I went on with the Wi-Fi cartridge. At least I think that's the order. Yeah. And the first design had so many mistakes, really just mistakes in the whole design of the circuit, the mistakes in how I communicated with the ESP8266 or the ESP12F in this case. That's the important difference there because I forgot all the pull-ups and pull-downs that I needed to even let it boot. Yeah. And I forgot an entire footprint for the socket holder of the EEPROM. I used an RGB LED, which drew way too much power. And there were so many mistakes in there that I couldn't even use it to test anything. And at that point, I was really wondering if I should continue with it because I was expecting that I needed many more iterations until I get it working. And I really had the impression that this was a little bit too complicated for the things that I have experience with, and I should start with something easier first. But luckily, I pressed on because, this was an interesting project, and I was really curious if I could do it. And the next batch of PCBs was the version that you see in the video. So the next iteration actually worked. I was able to fix everything that was a problem. There are some things in the design of the Wi-Fi cartridge which I would do different today. But I got it working. So in this case, the decision was right to press on. But stuff like that happens. And you really have to think at some point if the project is worth it. And if on one hand, what you expect on how much more effort you have to put into it. And if the result is worth it. And of course, the result can be the joy of developing it. So for this project, which I'm probably going to scrap, I'm not enjoying it anymore. So it's also not an interesting challenge, I think. For the Wi-Fi cartridge, I was very curious about a lot of the things, how they work. And so it was also interesting enough to press on. Next one. Do you have any further thoughts about the Intellivision Amico? No. Next one. How much time did it take to develop this thing? I looked up a few dates that are easy to look up to give you an idea of how long it took. So the first time that Tolstoy, that's the Tetris guy who told me about the requirement for some way to stream the Tetris competition. So the first time he got in contact with me was in July. It was the 11th. At that point, I did not immediately start working on it. So we were just mailing forth and back, switching to Discord eventually, and exchanging some ideas. I was also still working on this other project, the one that I'm probably scrapping right now. And I'm not entirely sure when I actually started working on it, but the next day that I can easily check is I ordered the first prototype in September on the 21st. So this first prototype actually was the one that was already working. I could run the entire thing as it is on this first prototype. The only thing that would not work is it did not have a detection to tell whether the Game Boy is turned on or not, but that's not that crucial. There were some minor faults on this one. As I mentioned before, the LEDs were the wrong way around and I had to desolder and resolder them. But in September I ordered them. Of course, from China it took actually quite a while until I got them. But the next thing I think that I can tell you is that on October the 30th, I did a teaser, an announcement of the GB Interceptor on social media. And the order for the final version of the PCB, the one that that I published and that you might be using right now. So I placed this order in November 20th. And then on December the 20th, I released the first version and I released a video about the Interceptor. And of course, if you look at the current version, you can since then have a look at the progress on GitHub. But the thing you should keep in mind with this is a very important part of how much a project takes, of course, is how much time you can invest in it. And it's just not just the days or the months that you spend on it, but for me, this really depends a lot on how much I can use the evenings. Because during the day, my family comes first, except for weekdays, where I, of course, have a day job. So on the weekend, as well as during the week, I'm not spending any time on these projects during the day. I only spend time on them in rare cases when the children are, for example, with my parents, so their grandparents. But usually I only do it in the evening after my son went to bed. And actually, during this session now, during this recording, my younger son already called me up into his room 3 times because he has a difficult time to sleep today for some reason. But yeah, I usually only spend the evenings, and only if there's nothing more pressing that's left to do from the day job or whatever else there is to do. Yeah, so it's really hard to put a number to how much time in hours I spend on this project. Yeah. Okay, so that's the meta stuff. Next, I've got the technical stuff and questions about possible future versions of the Interceptor. So let's start with this one. Would we see a revision 2 with wireless video capture or audio, potential capabilities for GBA or GB color? Well, okay, there's a lot in there. So first of all, the one thing that might be possible is the Game Boy Color. As I mentioned before, maybe some optimization could make it work, but at this point, I'm not that sure anymore because I don't think that my code is that bad, and it's really so far from being able to keep up with the Game Boy Color. So, adding a little bit more beef to the GB Interceptor to work with the GB Color, with the Game Boy Color, should be possible, I think. The next thing is wireless video capture. That's something I would not even try anymore, if I'm honest. So the thing is, the Wi-Fi cartridge has a big problem that it draws way too much power, much more power than the Game Boy can supply. Depends on the Game Boy model, how bad it is. My knowledge about electronics told me that I should add a huge capacitor there, but that only helped a little, and I do not really have a good solution on how to make it work reliably. So I'm very careful about adding any modern transmission device in there, because the power or the voltage converter of the Game Boy or the power supply for the cartridge is only designed to support an EEPROM, maybe the Game Boy camera as an extreme. It works with some modern flash cards, but some of you might have experienced how unsatisfying it is if they draw too much power. And the problem with modern devices, especially with Wi-Fi in this case, is that it draws power in short bursts, and this easily exceeds everything that the Game Boy can handle. I'm not sure, maybe Bluetooth Low Energy might work better. Should know about the bandwidth, because I already worked a lot with Bluetooth Low Energy, but not sure if the bandwidth should be enough. And if you think about other wireless solutions, it's tricky. Yeah, and I do not see that it's really that important, because first of all, if you want to improve the experience, I don't think that the cable is the problem, but more the bulky design of the Interceptor at this point. The other thing is audio. Audio is really problematic because emulating audio is much more demanding for the CPU, at least if you do it on CPU. Maybe you can do it with a dedicated device. I'm not sure how common devices are like the original audio chip. But if you recreate the waveform just on the microprocessor, that's so much more that you have to do on the microprocessor. I don't think that will happen. Although on the other hand, yeah, I'm thinking about the wrong orders of magnitude on which the calculations take place. So not sure if this might be possible. And then finally, the question is also about the Game Boy Advance. And the Game Boy Advance, I'm quite sure, will never work like this. The problem is that this will also already add a little bit to the next question. The Game Boy Advance is one of the devices where the difference between the medium for the game, for the game software, and RAM plays a role. So for the Game Boy Advance, we already have a situation where executing code from RAM is much faster than executing code from the cartridge. I'm not even sure if it can execute code directly from the cartridge. I'm not that familiar with the architecture of the Game Boy Advance, but reading data from the cartridge is definitely slower than from RAM. And at that point, it makes a lot of sense for the game to load large parts of the code into RAM first and then execute it from the RAM, which is not immediately a problem. The Game Boy does this in very rare situations too. But if the Game Boy does this in most situations, again with a little asterisk there, we can still see on the bus or the memory bus at the cartridge which addresses the Game Boy accesses. So we can still see which part of the code it has copied before is executed. And we know the code that's executed from RAM because it copied it from the cartridge. So the Interceptor can mimic the same operation and has the same copy of the code in its copy of RAM. And when the Game Boy executes it, we can see the addresses at which it executes it, and we can execute the same code. That's no problem. But if you do this on a system where reading from ROM or from any other medium is slower than from RAM, I'm very sure that you will not see the addresses of the RAM on the end of the cartridge for the Game Boy Advance because it's slower. It doesn't make sense to have the same shared address bus on both of them because it would really mess with the cartridge if you did. And so I'm very confident. I haven't tried it. I'm not too familiar with the Game Boy Advance, but I'm very sure that most of the code will be executed in RAM and you cannot see which code is being executed. And at that point, in combination with the problem that we already have on the Game Boy, that you do not see the player's input, there's no way to know what's actually happening at any moment. And even if the Game Boy Advance was executing code directly from the cartridge, the Game Boy Advance has some kind of cache that prefetches some of the data from the cartridge, so it would even read data from the cartridge that it's not executing. But again, I'm not that familiar with the Game Boy Advance, so you could look up the details if you want to, but I'm pretty sure that the principle of the GB Interceptor cannot be used on a Game Boy Advance, even with beefier hardware. And that, as I mentioned before, matches the next question. On which other systems is this approach possible? NES, Famicom, MSX, Game Gear, and add WonderSwan to the list. The same applies here. So it will not work on any system where reading from the game medium is slower than reading from RAM. I'm very sure about this. So first of all, MSX is probably out of the question here because you would execute from tape or from disk, which is slower than RAM. So I'm quite sure that it will copy everything to RAM first, and I'm very sure that you will not see it at this end. I'm not sure. I think there is a cartridge system for the MSX systems as well. Is there? I'm not that familiar with these things. So maybe for those, but I also don't think so, because another requirement is that the cartridge is memory mapped into the entire system. And I'm not sure if for the MSX systems this is the case, because they can have different sources. I really do not know enough about those, but I highly doubt it. I think it looks better for the NES or the Game Gear. Again, I'm not that familiar with those. I really learned everything about the Game Boy for my projects here, and I'm not an expert in all the other systems. But those are candidates where I think where we're at the point of technology where executing directly from ROM makes a lot of sense, because it's not slower and RAM is expensive, and they probably execute most of their code from the cartridge. So, but that's speculation on my end. I haven't researched this. And probably the same for the WonderSwan, although this one is, if I've seen it correctly, a little bit faster. It might already start moving into this GBA territory, where you use a faster RAM in combination with only half the speed ROM, but entirely speculation. So the important part of the answer is you need a system where most of the code is executed from ROM, or in the cases where code is executed from RAM, it's done at the same clock rate as from the ROM. So that makes sense for the system architecture to reveal the addresses that are being used to the cartridge. And this, of course, also only makes sense if the cartridge is memory mapped into the entire address range. Okay, so if you want to do something like that, first check if this applies to the system. And even then, of course, technically, it's not required that you can see any other memory access on the cartridge bus that is not addressing the cartridge bus. In hindsight, I'm a little bit surprised that it's the case with the Game Boy, because at first I thought it's just a shared memory bus for everything. But if you look at DMA operations, so direct memory access, where the CPU no longer has access to most of the memory space, but instead the DMA chip copies data from RAM or ROM directly to OEM, so the memory part that's responsible for the sprites. At this point, you see different addresses on the cartridge, because the cartridge may even be the source for the data for the DMA transfer, than the CPU sees, which is one of the tricky parts for the Interceptor, but which also makes clear that it's not physically connected and it can be disconnected. So, yeah, it's lucky for us that besides OEM DMA transfer, we can even see these addresses. So yeah, you have to check these for these systems if you want the Interceptor there. Next one. What tips would you have for someone wanting reverse engineer and build something like this for another device, possibly with higher clock speeds? Okay, first of all, if you think about reverse engineering the Interceptor, that's not necessarily, it's open source, yeah, but I'm not sure if you meant that. If you're thinking about reverse engineering the other system, I am probably not the right one to give you advice about this, because the Game Boy is very well documented by all the people who reverse engineered it before me. I did not do much reverse engineering. Maybe I figured out a few little details about it that were not documented somewhere. But if I was aware about something that I figured out, I would have tried to edit it to the pen docs or something like that. So I really reverse engineered very little. I'm standing on the shoulders of giants here. Yeah. So you should probably ask around in the emulation scene how they figure out some details if it comes to reverse engineering the system. When it comes to building something like the Interceptor for that system, about which you then hopefully know enough to emulate it, I would suggest to first check out some of the specifics, like can you detect interrupts? That's a critical thing on the Game Boy. That was one where I was lucky for the GB Interceptor that there's a solution for this. Just as a hint for the Game Boy, an important part is that interrupts only jump to specific addresses, which makes it quite easy to detect them. Next thing that you should check is are there cases where data is copied to RAM? I mean, that's pretty much what I said in the previous question. And if you are able to follow that code, if this happens, and if there are situations where you cannot see what the CPU is doing, like DMA transfers, and if this is rare enough or specific enough that you can work around it, for the Game Boy, for example, the thing is that this is only done very shortly, and the CPU mostly just waits for DMA to finish and doesn't do anything properly. So it's easy for us to work around this situation on the Game Boy. But this might be different on other systems. In other systems, it might trigger a DMA process, which occupies the cartridge, and in the background, the CPU is doing some really fancy stuff. So that would be possible too. So that's something you might check out, so you don't run into a wall there. Yeah, and besides that, I mean, checking this out might be tricky, because that's usually not documented by people who created emulators, because they do not deal with the data on the cartridge bus. They deal with the raw code of the system and they execute it themselves. So one thing that might be a good idea for you is to take the Interceptor, or actually not the Interceptor. Interceptor will physically not be compatible with the system that you're targeting it. Yeah, but take a Raspberry Pi Pico. Hook it up to the memory bus of the system that you try to create something like Interceptor for, and have a look at the code of the Interceptor and how the data is caught from the programmable I/O interfaces. That's 3 lines of assembly. That's a very simple thing, yeah, to use the clock signal to get the data from the data bus. But even if it is at a higher clock rate, the Raspberry Pi Pico should easily be able to capture these events just like a logic analyzer. Yeah, so you get some actual sample data from your system to figure out if it's possible to emulate what's going on from this data. It's probably at a higher clock rate not possible to emulate that thing at the speed, but you can still pick up a €5 or €5 Raspberry Pi Pico and hook it up to your system. Mind that the Pico is using 3.3 volts, so you probably need some boost transceivers or level shifters or whatever in between. But it should be enough to actually get real data from the bus so that you know what's visible on the bus and to evaluate if you can go on with this project. So yeah, that's my advice. The next question is similar to the last part of the previous answer. That's why I put it there. Would it be possible to use a different firmware for the Interceptor to use it as a data analyzer to see what is being written to RAM? Basically, turn it into a pure logic analyzer for the card bus. I know from the context of the question that this is not about just randomly analyzing everything on the bus, but this is about someone who wants to learn more about how the Game Boy camera communicates. And for this, you do not even have to create an entirely new firmware, but instead, for the Interceptor, look into the Interceptor code in the header file for the debug part, so debug.h. Because there are some lines commented out, which have some debugging tools that I use to analyze why certain games crash, which allow you to stop the Interceptor at a specific line that is read from the card or executed from the cartridge, as well as if data is written to a specific address or data is read from a specific address. And with these tools, you should be able to quite specifically stop the Interceptor at a certain point in the code. And what the Interceptor then will do via the serial terminal that you can access with Minicom on Linux or PuTTY on Windows, you get the last 256, now there's a little headroom at the end, so 230 or something bus events that it recorded. And you can even enable support to label them with the opcodes that are recognized and the state of the registers of the CPU. So this should help you to see specific events on the cartridge bus. So no need to entirely rewrite the software. You just have to compile it with these lines no longer commented out. Of course, if you want to do more than that, if you really want to record long stretches of from the cartridge bus, keep in mind that the RP2040 has somewhat limited RAM. I think it's around 260 kilobyte or something like that. It has way more flash, but you cannot use flash to record this because flash is slower than the rate at which you will be recording bus events. And because bus events come in at the memory clock rate of the Game Boy, which is about roughly 1 megahertz. So the 260 kilobyte of RAM of the RP2040 will be filled up very quickly. So you cannot just record the entire bus stream of you playing some game. But still you can collect much more data than what the Interceptor does with this debug functions. If you want to just look at the code of the Interceptor, throw out everything that you don't need, and increase the size of this ring buffer or this array, which collects the bus events, and you should be able to see a little bit more. But still, you cannot just record everything, and you cannot stream the bus via USB. That's also what some people sometimes ask, if I could do emulation on the host PC and just stream the data from the bus there, because what you need at least is the address pins of the data bus, which is 16-bit, the data itself, which is 8-bit, and you might get away with ignoring the other pins. So there would be a read-write flag, or actually read flag and a write flag. They are separate. Chip select flag, and the clock itself is obviously synchronous with the event. So there are 3 more bits that you maybe could drop, but this still means that you have 24 bits per bus event. That's 3 bytes per event with 1 million events per second. That's about 3 megabytes per second, and that's more than this USB 1.1 bus can do. So you can use the Interceptor as a logic analyzer, but you're limited, of course, by the RAM of the device. But then again, you're probably not going through 100,000s of bus events by hand, so you just have to be clever about picking out those events that are interesting to you. Next one. Could you please explain more about why almost every CPU instruction passes through the cartridge port? I would have guessed that something like, for example, pressing a button to move a Tetris piece wouldn't have required reading anything from the game cartridge. Obviously, that's not the case, since you are able to intercept that instruction. Is the RAM just that small that it needs to retrieve such simple game code in real time, or is there a different explanation that I haven't considered? So it's not even about fetching the code because the RAM is so small. It's more about that executing the code directly from a cartridge is as fast as executing it from RAM. So the code that's executed, depending on which button you press, is, I think, technically it's fetched from the cartridge, but I think that's not the ideal term. The ideal term is it's executed from a cartridge. It's never copied to RAM. So the CPU actually reads one instruction after the next one from the cartridge, and therefore we see which part of the cartridge is being executed. So that's a very simple answer to the question on why every CPU instruction passes through the cartridge port, because it's actually executed from there. Exceptions are extremely rare. So one exception is if DMA is used to copy data directly from RAM or from the cartridge to OEM. That's the memory that controls the placement of sprites. And this is a funny thing because the CPU doesn't even do anything differently during this time. The problem is that, so DMA means that there's a little coprocessor, let's call it an assistant, so a little PA, a personal assistant to the CPU, which executes the simple, small task of copying something from one part of memory to a different part. So on a modern system, you do a lot of DMA stuff. So the CPU then says, okay, DA, come over here. The DMA chip that handles this. I need hundreds of kilobytes copied from RAM over there to, I'm not even sure, the hard disk. Not sure if that's DMA, but I think so. Can you do this? I've got more important stuff to do. Okay, and then this assistant for the CPU copies all the stuff while the CPU does some other calculations that the CPU can do, which the assistant couldn't do. On the Game Boy, it's a little bit different because as soon as DMA is copying, the CPU cannot access RAM anymore, not the regular RAM at least. It cannot access the cartridge anymore. It can only access high memory. So this is the address space of FF and then the I/O registers, which are in the range of FF00 to FF80, and the high RAM, which is FF, actually 80 belongs to high RAM already, FF80 to FFFF. And that's not a lot of things the CPU can do there, because half of this is not RAM, it's just I/O registers. So it has 128 bytes of RAM available. Maybe some of it is still used by some other part of the game and you don't want to copy it out first. And these 128 bytes have to hold the instructions of what the CPU is doing during DMA. It has to hold the data it is doing something on. And of course, it has to hold the result of what it's doing. So there is not much the CPU can do during DMA. So 99% of the games simply load a simple routine into high memory, which just loops and counts off the time DMA takes to jump back into the code after DMA is finished. So it's like, not sure, 6 instructions or something like that. So instructions to start the DMA transfer, and then, 1 or 2 instructions to count down, and a conditional jump to continue counting down until you finish counting down, and the return instruction to get back into the main code. That's all they do. So there's nothing happening there. That's one of the few exceptions where the Game Boy even executes something from RAM. Another example might be code that changes, that's supposed to be changed to be more efficient in some very time-critical times. So there sometimes might be code copied to RAM because the game optimizes it for different parts of the game so it can execute quickly without conditional branching. But I'm not even sure if I really observed it somewhere. At some point, I thought I saw something like this, but I didn't really investigate. So pretty much anything that the Game Boy does is executed directly from the cartridge. So the button presses then do not go through the cartridge itself, but it simply means that if a button is pressed, a different part of the code is being executed. And from point of view of the Interceptor, it's not even a matter of making this decision. It's just the interceptor is just seeing the code that's executed because of the button press. So the interceptor simply behaves in the same way as the Game Boy. The Game Boy made the, I would almost say, conscious decision to execute the code that in the video I talked about, in the main video I talked about making Mario jump. Yeah, so it decides to fetch the code that makes Mario jump, and the interceptor just sees that this code is being executed, and it executes the same code. Has no idea what this code does. Has no idea that the button triggered it. It just executes the code, and that code makes Mario jump. And so we are quite lucky that it works this way, and that's the reason why I mentioned earlier that there's no chance to do something like this on a system where code is not executed directly from the cartridge, or at least in those cases where it's executed from ROM, the cartridge is running at a different speed, because then you can be quite sure that you cannot see which addresses are being used there. And at that point, you're absolutely right. You would have no way to tell what button was pressed or what the game is actually doing. Okay, next one. What changes would need to be made to make this work like a Game Genie or Game Shark device? Would it work across all Game Boy models, DMG to SP macro? Can the interceptor act as a Game Genie? Can the interceptor overwrite game tiles with one stored in the RP2040? Okay, so I should have switched the order of these questions, because the second one is about can it do? Answer is no, it cannot. Right now, the cartridge is directly wired to the cartridge port on the Game Boy. You cannot see it from the device itself, but if you take out a multimeter and measure the pin at the Game Boy and the pin at the cartridge, you will see that they're directly connected. So there is no way to interrupt the signal. It's called interceptor, but doesn't really intercept in the sense that the data doesn't go through. It more or less copies it, but the GB copier doesn't sound that nice. Yeah. So there's no way to prevent the cartridge from answering anything that the Game Boy is asking for. So we cannot just push our data into this. Also electronically, the boost transceivers are wired in one direction. So they only transmit the signal from the connection of the Game Boy to the interceptor to the RP2040 and not the other way around. So it cannot act like a Game Genie. It cannot influence the gaming experience on the Game Boy itself at all. So that's was a very intent design decision, because I wanted to make sure that people understand that playing it on the Game Boy doesn't change anything at all. So what you see on the Game Boy is exactly the same, except for having a long thing sticking out of it and maybe mechanically having the torque, that might interfere with your gaming experience. But just from the logic of the game, nothing changes at all, and the interceptor is not able to change anything of that. I think this also is what this question about replacing game tiles is aiming for. So you cannot replace game tiles on the Game Boy. Of course, Interceptor could change the game tiles that it uses to render its video stream for the USB connection. That could differ from the Game Boy itself. That's possible, but it cannot change the game tiles for the Game Boy, for the physical Game Boy. What changes would need to be made to make this work like a Game Genie, Game Shark device? Electronically, you need to control the bus transceivers, and you need to be able to disconnect the cartridge. I think it should not be too hard, because there are several chips to achieve exactly that. And I'm also quite sure there will be some that can also handle the shift in logic level. If not, then you put some logic level shifters in between. So electronically, this should be possible. One problem might be that the RP2040 doesn't really have any more GPIO pins available. But then again, it could work without the mode button and this LED, or it could work without detecting if the Game Boy is turned on. I think we could probably work around this. So electronically, it should be possible to do this. It might be an interesting project. If you do this, it should work with all Game Boy models, at least the one that use the old format. So if you're asking about the SP, it would not work for Game Boy Advance games, because those are electrically different. So the Game Boy Advance actually has a little pin in there that's being pressed by the cartridge, and the old cartridges actually switch the entire hardware to a little copy of a Game Boy Color that's inside the Game Boy Advance. So these work at 5-volt logic and have some other differences. And Game Boy Advance games would not work in the same way. So that would not be compatible, but any of the old games should work with this. And if you're thinking about creating your own game Genie, that would also work with Game Boy Color models, at least if your code does not do too complicated stuff. If you just want to inject some code or replace some requests, you should be able to keep up with the double clock speed of Game Boy Color devices. If you want to emulate the entire thing, yeah, then you probably run into the same problems as I do, but the question sounds like you want to create a game Genie, and for that one, you probably also don't have much of a problem for the speed, because you pretty much only need a lookup table for specific addresses, which you then for which you then switch the external cartridge to the output of the RP2040 and replace it with the data that you want to send. Maybe switching fast enough might be tricky. You really have to be careful about the timing, that you do not create a problem that the EEPROM answers too fast. But I think that should also be possible, because you can see the address early, and the actual cartridge, the real cartridge, answers at a certain flank of the clock signal. And if you can see the address earlier and log onto the signal a little bit earlier, you can probably disconnect the cartridge in time so that your answer gets through. But that timing might be a little bit tricky, but I think that should be totally manageable, especially with the programmable IOs. I mean, you already heard by now, I love those programmable IOs on the RP2040. They should also come in quite handy to do this in time, and also especially to switch the direction of the boost transceivers in time. So I think that's possible. Yeah. Next one. Any idea on how to make it 100% compatible with all Game Boy games, like code injection that reads button input or something? Yeah, I think at this point we should probably look at why some games do not work, and then we can think about this. Because at the beginning, I already showed you the long list of games that work, and as you see, at least in this list, I calculated, 1.67% of games only do not work at all, or at least glitch so much that it doesn't make sense to use them with the Interceptor. And we can actually have a look at these 3 games. So I think the easiest example would be Dr. Mario. In this one, the diff register, so it's an internal counter of the Game Boy that counts very fast, is used as a source for random numbers. And the Interceptor cannot emulate this properly. This has several reasons. One of the reasons is that we need to detect which type of Game Boy we are on, because at the beginning of when the Game Boy was turned on, the starting value of this diff register depends on the Game Boy model. But unfortunately, also on some models, like the Game Boy Color, it depends on user input, because the diff register already starts counting during the boot ROM, and boot ROM takes longer if you change colors on the Game Boy Color, for example. This already makes it really difficult, or maybe even already impossible, to emulate the diff register properly to get the same numbers as the real game. The other problem is that the Interceptor still does not have a clock that is in perfect sync with the Game Boy clock. So what the Interceptor does at the moment is, during the boot ROM, it records a number of, I think, 1,000 bus events, measures the time compared to its own clock to figure out a ratio that it can use to use its own clock as a substitute for the clock of the Game Boy. And it needs this if a game uses the halt instruction, which pretty much every game does. So when a game has everything calculated for this frame, it conserves some battery on your Game Boy by calling the halt instruction. This means that the clock is turned off on the cartridge, and I think the CPU also goes to sleep and preserves some energy until an interrupt is called. In most games, it's the VSync interrupt. So when the frame finished drawing and the CPU has to do some stuff again. And during this time, since the clock is turned off for the cartridge, we do not see the clock of the Game Boy anymore. And at this point, the Interceptor needs to emulate its own clock with its own reference clock of its own CPU. And we're talking about thousands and 10,000s of clock cycles, depending on the game. And here we might lose 1 or 2 cycles, which is not that bad, because the diff register does not increase on every single cycle, but over time it adds up, and eventually the emulated diff register will desync. So maybe this part can be solved, but still the different initial state of the diff register is still tricky. That's something where code injection might help, because you could reset the diff register at certain points. You just have to make sure that it doesn't break the functionality of the random number generator. So you have to make it at some point where it's, where it still is random after some user input, but you can stay in sync somehow. Maybe it makes more sense to inject some code that exposes it on the bus somehow. I mean, you should be able to trigger writing to the cartridge at any point. Just use some safe address space, even if the cartridge doesn't support writing to it. So you can write back the data from there. You just have to make sure that you inject the code at some point where it doesn't break the timing of the game itself. That might be possible. So maybe that would be a solution, but then you have to refer back, of course, to the game Genie question. Not the first one where we tried the game Genie, but the one if the interceptor can act like a game Genie, where the answer is currently not. So the interceptor itself cannot do this at this point. So a modification where the interceptor acts like a game Genie might solve this. Okay, so that's one example. The other example is similar. So let's just, what was the other? Oh yeah, the other example was Super Scrabble. Who hasn't always dreamt of playing Super Scrabble and streaming it with the GB Interceptor? But yeah, who knows? Super Scrabble goes one step further in its random number generation, because it uses the uninitialized memory of the Game Boy as a seed for a random number generator that's based on the diff register. So yeah, that's quite a mouthful. What it does is when you turn on the Game Boy, it does not initialize its RAM to 0 like you would expect from most stuff that's created by a C compiler. Instead, all the RAM is in this random state. And Super Scrabble actually loads one of these initialized values into the diff register. Oh no, actually not into a diff register, but into a counter, which is then counting up internally. So it's just counter implemented by Super Scrabble, but it's the same principle. It counts up and it starts with a value that's from uninitialized RAM. So that's definitely a value that we cannot know at all. Then during the main screen, this value also counts up. And when you press start, the counter stops, and this value is used as a seed for the random number generator to create your Scrabble field. The solution should be the same as for the previous one. Once you press start, it would be great to inject some code that then retrieves the seed value for the random number generator. And I think from there on, it should be not that much of a problem. Although I did not look into the details of the code. Maybe at some other point it still reads some more data, then you have to inject more code and can of course get complicated. But I think this should also solve this. Another case where I don't think that simple changes will help here is Prehistorik Man. So yeah, we looked at this. This was one of the questions, what the interceptor does with Prehistorik Man. And the problem here is that Prehistorik Man has one graphic effect. So this big font that draws over the game, which relies on intraline timing. I explained this when we discussed this game. And still the same problem applies. As long as we're doing USB communication on the same core that we use for drawing these lines, I don't think that we can get the precision that's required to make this font look correct. One thought might be a separate USB chip, which then caches some responses and data, maybe something that's specific for USB for the USB video class. I'm not sure what exists there and if it's expensive and if we can use it like this and if we really can transfer entire frame to this chip to handle communication and then the core can deal with something else. Another solution might be just adding another RP2040, so send in more troops, and this where one core handles USB communication and the other RP2040 can handle everything else, and then you have to figure out how they communicate with each other, with one of them having all GPIO pins already blocked. I'm not sure. This might also be a problem when adding an external USB chip. I haven't thought about this when I discussed this USB part. Maybe something like that, but this is one that's not on a logic level, but this is really a limitation of how fast and how precise we can emulate the graphics unit of the Game Boy. So yeah, that might be a problem there. Yeah, I think that mostly covers this question. It really depends on the game. Yeah, so that's the answer. And I might find even some other reasons why specific games do not work out properly. Okay. Yeah, and it's almost foreshadowing that my screen went into standby back there while I was talking. Because we get close to the end, so there's one last technical question here. You mentioned that you didn't have the audio pin hooked up, so there's no audio. Does that pin provide a real audio stream, or would the Interceptor need to run an audio emulator to process the data into audio? These are actually two different things. So the audio pin on the cartridge is an actual analog audio signal. So if I wanted to capture that one, I actually need to sample the analog signal at a suitable rate for the audio. I'm not sure if it makes sense for a Game Boy to sample it at 48 kilohertz like you usually would do nowadays in CD quality, but something in this range, like then maybe 24 kilohertz. I'm not sure how much would be necessary there, but that would be quite tricky and would require some additional hardware. I'm quite sure about this. Or maybe I'm not sure what the programmable I/O can do, but it cannot do analog. So maybe combination with shift register. I'm not sure what people came up with already. Probably someone did some fancy stuff with the programmable I/O for this. But the thing is, it's not necessary because I do not know of any game that ever used this audio pin. Of course, I do not know that many games, but that's pretty much a sentence I found every time someone discussed this audio pin. It seems like no game ever used it. So no reason to connect it, no reason to emulate this. But the actual game audio is a somewhat different story. This works differently. The game audio is controlled by the game or by the CPU by writing specific values to specific registers. So, and these different registers control the four audio units or synthesizers of the Game Boy. So if you want to know it in detail, you should look it up because I'm not that familiar with the audio part. But I usually recommend the Ultimate Game Boy Talk. So that's also covered in there, at least an overview of it. So the Game Boy has four synthesizers or four waveform generators. I'm not entirely sure. I think 3 of them can generate sine functions. 2 of them can shift between a sine function and a rectangular function with different duty cycles and stuff like that. And the third sine generator can actually be programmed with an arbitrary waveform. But arbitrary waveform means that I think 32 samples or something like that, not like you can load a wave file into it. And the fourth one is a noise generator. So it can generate white noise for sound effects. And they've all have special properties. But what you basically do is you write a frequency that you wanted to play into a certain register, an amplitude, maybe some information about the envelope function on decay of the sound, or maybe I think one channel can do a frequency ramp. Many of the iconic Nintendo sounds are based on this effect. And stuff like that. So you can control these like musical instruments, pretty much similar to MIDI. Yeah. So you tell it play a frequency of that at an amplitude like this at this moment and for this duration and this envelope function. And this means that the RP2040 needs to take this information. It has this information. This works. This is something it can pick up, and I haven't looked into it, but I'm very sure that it's present at the Interceptor. But it then has to recreate the waveform with this, which means that depending on the quality that you want, it has to create 4 waveforms at 48 kilohertz, mix them together, and then somehow output them. In terms of the USB stream of the video stream, it would have to add a wave channel and add it in there, which also takes away some of the bandwidth of the USB video class stream. And I'm a little bit skeptical if we have the headroom for this. Now that I think about this, the interesting thing about audio is that it's occurring at a very different order of magnitude for the frequency. So we're talking about 48 kilohertz, while the CPU, the one that I'm always skeptical if the Interceptor can keep up, is working at 1 megahertz. So there might be a little bit headroom there. But then again, this means that, let me quickly calculate, if we're talking about 60 FPS, this means that we need so if you're looking at 48 kilohertz audio, you could maybe get away with 32 kilohertz or something like that. This means that we have to calculate 800 samples of audio for all 4 channels per frame. And yeah, I think you can get away with pure integer operations there. At least I think so. For sine functions, you can use lookup tables. So maybe it's possible. Not sure. But as I said, the cores of the RP2040 already have quite their hands full. So this would be equal to blending 5 more lines. So okay. So maybe I should try it at some point. I'm not entirely sure. Okay, so I always thought it was much more to calculate there. Now that I tried the numbers, I think it might be possible, but it might be a close call, especially as it has to fit in there somewhere between doing the graphics units emulation and the USB communication. I mean, that's already the reason that Prehistorik Man does not work properly. But yeah, I also thought it's not that relevant because you can always capture the audio directly from the audio jack on the Game Boy. But of course, it's more convenient if you get it with the video stream. So maybe I will try it at some point. Okay, so those were the technical questions. There's one more question that I had twice. So it's what's next? And do you have any other projects in the works? So yeah, the next project that I'm already working on, which I briefly mentioned that this is the reason that the next major update for the Interceptor might be in 2 months or something like that, or it will start working on it in 2 months, is a project for my cousin's wedding. And it has to do with video stuff. So it's more in the line of some of my earlier videos where I do some things with cameras. I don't want to go into too much detail right now. But yeah, I've been thinking about this project for quite a while, and I've always thought that this wedding might be a great moment to do this, but thanks to the pandemic and some other reasons, there wasn't a definite date for this, and now he announced it on a rather short notice. So this is the project that I have to do right now, and which I already quite excited about. It's not that complicated in terms of coding. That's a simple afternoon stroll in Python, I would think. But it's still an interesting project and something I always wanted to do. But so yeah, stay tuned for this one. But if you're more thinking about retro gaming, there's one project for the Game Boy I want to do eventually. I'm not sure when I will do this so far. I mean, 2 times is a tradition, right? So tradition is to release stuff on Christmas for me. So Game Boy stuff, the Wi-Fi cartridge was released around Christmas, and the GB Interceptor was released a few days before Christmas. So maybe the next one I will also aim for Christmas. Not sure. Yeah, there's another cartridge with some modern tech in it that I want to do. So maybe I will do this next after this wedding project. And also, I really want to do something with the Super Nintendo, because those are the 2 relevant consoles from my youth. Actually, there are 3 relevant ones. So it's a Game Boy, it's a Super Nintendo, and it's the N64. Those are the ones that I have fond memories of. So I would really like to do something with the Super Nintendo. I have no specific idea. So if you've got some suggestion, tell me about it. So if I eventually have an excuse to buy a Super Nintendo and to look into how this one works. But it's nothing specific. So if you've got any suggestion, I would like to hear about them. So, and yeah, these were all the questions I received. I think this video is already long enough, even in the edited version. I hope you found it interesting. I hope you learned a few things about this. And I hope to see you around, even if the next video is not about retro gaming. If not, I can at least tease that I want to eventually return to retro gaming at some point. So stay tuned and see you soon.